Hello guys, and welcome to my YouTube channel. This is my version of a small 150 watt portable lab bench power supply. As you can see, I designed and 3D printed the enclosure, while the electronics are based on an inexpensive off-the-shelf module, the ZK150. The removable foot is attached magnetically, and the magnets are surprisingly strong. This allows the power supply to be positioned in multiple orientations while remaining stable on the table. First, I am going to power the device with a 3S LiPo battery with a XT60 connector. Once connected, the power supply starts up immediately. I really like the user interface. It features a rotary encoder. Since the main module is commercially available, it can be purchased quite cheaply from AliExpress. I also have the add-on for Bluetooth. Here I am using my Bryman multimeter to verify the output accuracy. As you can see, the voltage output is almost exactly 12 volts. Now let's check the current. The current measurement shows a slightly larger deviation, but it is still more than accurate enough for practical use. Next, I connect a load to the output. In this case, I'm using a heating element. I set the power supply to a constant current of 8 amperes, resulting in approximately 35 watts of output power. As you can see, the heater warms up quite nicely. For me, the buck boost feature is a must-have. Now I want to demonstrate the USB-C input and output functionality. For me, it was very important to be able to power the device with my power bank or to use its output to charge my laptop. Here, I connect my power bank to the power supply with a USB-C cable. The USB-C input supports up to 140 watts and input voltages of up to 28 volts. The DC inputs, including the banana jacks and XT60 connector, can accept up to 30 volts. The USB-C output also supports up to 140 watts, providing up to 20 volts at 7 amperes. As you can see, the power supply charges my power bank without any problems. For this demonstration, I am supplying the unit with 24 volts because the module does not include a boost converter. Therefore, to get the full 140 watt USB-C output capability, the input voltage must be above 20 volts. Here is my USB-C tester. After a few attempts, it displays the supported power profiles, which you can see on the screen. It has very rich protocol support. Finally, let's take a look inside the device. I printed the case with my Bamboo Lab X1C printer and PETG filament. The enclosure is assembled using M2 screws and can be opened easily. Inside, you can see that the design mainly consists of readily available modules, making this project inexpensive and easy to replicate. You can also see the magnets that allow the accessories to attach securely to the enclosure. This is the USB CPD trigger module, which I configured for 28 volts operation by only jumping the second solder bridge. Here are the various modules, connectors, and cables used in the build. It's a good idea to solder on the cables before mounting the connector in the casing. The enclosure itself contains 5 threaded heat inserts for assembly. After installing the modules, I add the main power supply board together with the Bluetooth. If you are interested in making your own, please check the video description where I have a link to the Maker World page containing all the necessary 3D files. The Maker World page also contains a materials list, schematic, and a short how to build guide, which breaks down the building process into 7 simple steps. Thank you for watching, and if you enjoyed my little showcase, please leave a like or write a comment. Goodbye.